Hello बच्चों, so let's read the question. The question says that the moment of inertia of a body about the given axis is 1.2 kg meter square. Initially the body is at rest, and in order to produce the rotational kinetic energy of 500 joules, an angular acceleration of 25 radian per second must be applied about that axis for a duration of, so we have to find the time, the duration, and there are four options. So before that, let's know the key concept. So here the key concepts used are, the first one is the rotational kinetic energy which is equal to half I omega square, where I is the moment of inertia and omega is the angular velocity. The second concept used here is the rotational equation of motion. So rotational equation of motion is omega square, omega is equal to omega naught plus alpha t. Here omega is the final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is the time period. So we will be using these two concepts here. Okay, so here we have to calculate the time period, the time duration. So for that we are provided with the rotational kinetic energy. So it is equal to kinetic energy is half I omega square, which is equal to half I is the moment of inertia, which is equal to 1.2 kg meter square, and omega square is not given, but the kinetic energy is equal to 1500 joules. So using this particular equation, we will be finding out the omega, the angular velocity. So let's calculate half 1.2 into omega square is equal to 1500 joules. So omega square will be 3000 divided by 1.2, which will be equal to 2500. So here omega is equal to root 2500, which is equal to 50 radian per second. So this is our angular velocity, which is 50 radian per second. Now we will be calculating, what we exactly have to find out is the time period, right? So now we will be using the rotational dynamics, the equation of motion in rotational dynamics, which is omega is equal to omega naught plus alpha t. This is the first equation, right? This is the first equation of rotational dynamics. So here, applying that equation, omega is equal to omega naught plus alpha t. Here omega naught is the initial angular velocity, which is equal to 0 as given in the question. कि जो particular body है वो initially rest पर थी, जिससे पता चल जाता है ओमेगा नॉट 0 होगा. Next, omega is equal to alpha t. So alpha is given in the question, which is equal to 25 radian per second square. So here applying this, and omega we have calculated. So using this equation, 50 upon 25 is equal to t. We have just divided omega by alpha, which is equal to t. So here t will be equal to 2 seconds. So this is our correct answer. So from here we can click on option B, which is equal to 2 seconds. I hope you understood it well. Best of luck.